Hey everybody, this is Larry. This is me going over day 22 of the October Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know how you feel. Let me know if I'm too noob for you. Today's problem is minimum depth of binary tree. Find its minimum depth. The minimum depth is along the shortest path, the nearest node. The node is okay. So I mean, this seems pretty straightforward. I definitely recommend everyone practicing it. Yeah. I mean, I'm going to do it the depth first search way, but if you really want, this may be an opportunity for you to try the Morris traversal, which comes in place sometimes and pretty fancy and allows you to get constant space. But yeah, I don't feel like I worry about that. So yeah, so basically the thing with tree problems is two things, right? There's recurrence or recursion and invariant that is based on that recursion, right? So the thing to note is that, okay, if node is none, then we just return 0. Also, if is the depth is 3 minus 2. Okay, just want to make sure that is the same. One thing to note is that the distance between the root to a leaf is the same distance between the leaf to a node, to the root, right? I know it may seem obvious to say out loud, but this symmetry allows you to kind of figure out the distance going the other way as well. And that's how I kind of count up, if you will. Depending on how you want to think about it, right? So basically, is this node a leaf? That left is none, and no that right is none, then just return 1, right? Because that 1 is because it's the edge going upwards. And then now yeah, otherwise return the min of depth first search of node that left node that right. I think this one actually is wrong. I think you have to be careful, because if you have like essentially like a linked list, your left would be 0, but that doesn't mean that it gives you a 0. So actually this thing is wrong. What we want the base case to be is to be some infinity. Okay. So now we can just return from the node, from the root rather. Maybe it's off by 1 now, but I think this is it's the min of this plus 1 for going downwards. Though again, maybe this is off by 1. I don't think this is quite right. This feels a... No, this is okay. Yeah. Maybe 1 node, 2 node, and that's maybe it, right? I don't know how the number of nodes could be 0. I don't know. I think we return infinity, which would be wrong. So good thing to look at the constraints, right? See, so a little bit of gotcha. If root is none, return 0. Cool. That would have been a 5-minute penalty on a contest, but let's see if I get another one. Cool, looks good. Click on more detail. Oh, some people like to see submission stats. I don't know. I don't really generally pay attention to it. It actually doesn't even show up. Oh, seems like my running time is really slow. It's okay. But yeah, so this is linear time because we look at each node at least once, and in terms of space, it's gonna get dominated by the stack space of the depth first search, which means that it's going to be O of h, where h is the height of the tree, or O of n in the worst case. Again, you could do fancy things like the Morris traversal to kind of cut that down. Definitely, if that's something you want to practice, practice the thing that you want to practice. It's as simple as that. And you feel like you don't care about it, that's okay too. Practice later. But that's all I have for this problem. This, for the first time in a while, it's an easy one, at least for me. Hit the like button, hit the subscribe button, join me in Discord, and I will see y'all tomorrow. Bye bye.